Okay, in these sections, I'm gonna talk about energy emission and EV in SUMO particularly. So there are 4 topics. One is energy consumption and emission model, which we're gonna focus on HBEFA, and then we have SUMO emission models, and we're gonna talk about SUMO application in energy and emissions, and we have at the end of the day a hands-on experience on energy emission and EV. We are gonna open SUMO and then create these things and then play around to see how that works. Okay, so for the emission model, this presentation is just focusing on the HBEFA model, which is proposed, which stands for Handbook of Emission Factor for Road Transport, and it has the capability to calculate both energy and emission. For the electric vehicle, we're gonna use the SUMO electric vehicle model, which the reference is here. So this is HBEFA model. It includes a range of different vehicle categories like passengers, LCV, HCV, buses, motorcycles, and then it has a different fuel types or emission pollutants, right? And then the website is here. You can go to this hbefa.net and then you will see the handbook is not free, but you can get a lot of references about this because this is very popular, and SUMO is mainly based on this. So these are the SUMO emission models they listed in their website. So let's go here and then check these. So as of 2025, you can see we have this. It might be updated once you see in future this video, but we have HBEFA version 4.2 for now, but 5, 6, 7 they might come, right? So if I select, for example, so this is a good comparisons between different models. So what I can add is this HBEFA. The latest version is better. Okay, so as you can see here, also the electric vehicle model, for example, they don't measure, of course, the pollutant, the fuel. It just measure the electricity, right? So then you can select all of these and then just go here and read this, but I'm gonna just skip this part, go back to PowerPoint, and okay, I have a good news. So the good news is we only assign emission class in SUMO, and then it will automatically calculate everything for us. So we are not gonna go through speed, acceleration, deceleration, road gradient. So these elements affect basically the emission and energy, right? If you brake, accelerate more, if you have an elevated road, so these will affect. So these are important elements, just keep in your mind, and then we can move. Okay, so these are the SUMO applications in energy and emissions. As you can see, we have the first topic, which I am seeing a lot, is mixed traffic of EV and ICEV, which is those traditional car, right? And then they calculate energy and also pollutant. So what that means is what they do is creating a mixed traffic. Consider intersections nearby your home, right? And then if you put, for example, 80% of the vehicles as ICEV and then 20% as EV, so what's the results on the emissions and energy, right? So, and then if you change this percentage, how that looks, right? So same things, again, we have mixed traffic of AV, autonomous vehicles, and ICEV, right? Again, we can calculate these measures. Again, if you consider the same intersection, now 10% are AV, for example, and 90% are ICEV. What's the impact on energy? So I'm seeing these topics are coming, and they are hot topics. Also, another one is alternative design for infrastructure. Let's say if you change the intersection to a roundabout, right? What would be the impacts on the energy and the fuel? And especially if you have a mixed environment, so you have many scenarios, right? And then another thing is in digital twin and the real-time simulation environments. So what would that impact? So what I'm gonna focus on this presentation is the left side, which is the mixed traffic of EV and ICEV, but the rest of this is also can be very straightforward, except this digital twin one, which I'm gonna create another video later on. Okay, so let's move on hands-on experience on energy and emissions. SUMO, I'm taking this article as an example, energy savings and emissions reductions of BEV at an isolated complex intersection. So the journal that they publish is a very good journal. And then they have these vehicle types, ICEV, which is basically that combustion engine vehicle, and then BEV they are mentioning here, battery electric vehicles, and then BEAV that is, I think, kind of battery and autonomous electric vehicles, similar to maybe Tesla, right? Okay, so and the goal is how they reduce energy consumption and emission at the complex intersections, right? Okay, so they have different parameters here. Let's let's go to SUMO, and then first create a folder called Energy, Emission, and EV. So for this tutorial, I'm gonna use 1.24, the version of the SUMO, and then go to these folders, and then here open netedit. Okay, so now let's create change the number of lane to 3, and then create a small intersections here. Okay, and then select these lane tools, hold shift, select all, or simply you can just select all of this one by one like this, and then right click, edge operation, add reverse directions for edge, and then go here, processing, compute junctions. So now you press escape, you would have your intersections ready. Now we're gonna create 2 vehicles here. So one is the normal traditional vehicles, so we can just use the trip. If you want to use flow later on, you have more vehicles, you need to use this, but I'm gonna just use trip. And then the parent, the default, the parent type is default vehicle. So I'm gonna just add this here, and then we need to create a vehicle for an electric vehicles, right? So go to the vehicle types, and then here we need to, if you see there is no any electric vehicles, so just press on create type, and then here say EV, and then change this passenger to electric vehicle. And then now I'm gonna open this extended attributes. You can see all of the attributes for electric vehicles here, and then the length, mini gap, max speed. So I already explained about all of these things in another video, which is the SUMO vehicle types. If you go to the websites, you can just see the video here. And the important thing here is the emission class. If you remember, I talked about the emission class and told you that this emission class, if we change, it automatically calculates everything for us. So for this, the emission is 0, right? but the energy, which is the electricity, is not zero. Okay, so for the electric vehicle, but I'm gonna just accept this for now, and then we're gonna save all the files. Go here and save network. Just put a very short name like EV, and then save netedit again as a EV, right? So make sure that you save basically in these folders here, and then save the SUMO CFG file again as EV. Okay, so okay, we didn't add the electric vehicle yet, so go here in this creating vehicles, okay, and then just select the EV, select here and here, and then finish. So you have the EV here. Again, select all of these to save your files. So I'm gonna close this and go here to this SUMO CFG file, and then increase this delay a little bit, and then run. So if I change it to real world, you can see the electric vehicles here, and then this guy here, right? So what I'm gonna do is also I'm gonna add a traffic signals here, just a fixed one. So go here in network, this traffic light, and then here select create, and then it will select again, save all of things by just select everything here in saving icons, then it will save for you. So let's go back to the PowerPoint. So we were here, right? And then this table is coming from the paper. So we're gonna change some things here in the parameters of EV. Okay. So, but before explaining about these things, one thing that we should do is, if I go and simply now run this SUMO CFG file, right, then it ends and nothing happened. So where is the reports for emission? How we can understand if there is an emission results or something, right? So for that, what you need to do is, first you need to go to demand and make sure that your combustion vehicle has an emission model. So it uses a default vehicle type, right? Go to the vehicle type, and then this is defaults. Go to the edit, then you will see that emission class is this BEFA for PC petrol Euro 4, right? So I'm gonna just increase this if I can. I'm not sure. Okay, in this version I cannot, but let's just copy paste this, okay, to ChatGPT, and then we can ask AI what this means in SUMO. Okay, so it will think, and then it will but if you see here, there are a lot of models. Okay, you can select this, and then based on the vehicle types that you have, based on the emission models that you want, right? But so I'm gonna just wait for ChatGPT to answer this. What I can understand is this is HBEFA, okay, and then the 4 means the version 4, okay, and then PC is a passenger car, petrol is a fuel type, and Euro 4 means that the car is mid 2000 something, right? You can use, for example, Euro 6, or you can change this to a little bit, but I'm gonna just leave it for now, okay, and then accept it. And there is one more thing that we need to do here. So let's just close this one. I think this, yeah, is if we go, and the electric vehicle is already has the model, right? So go to the processing and SUMO options, and then here search emission, and then you need to select this emission output, and then I'm gonna save again emission, for example, right? And then save this file, and then basically we determine where we should save the emissions results. And then when I'm gonna go to this SUMO and then run, and then it will run for us. So let's just run it again, because you don't see the vehicle. You need to increase this delay to see the vehicles, okay? And then if you decrease this delay, the vehicles are just gonna go, and then yeah, the result is ended. So now if you see, there is one XML file which is interesting. Let's open it with the Notepad++ or Notepad, and then you have these results here. So each second, let's say the time is 0, the time is 1, 2, you have 2 cars, and some information is interesting, right? So let's say for T0, which is that ICEV, right, the combustion engine vehicle, we have the E-class model that we talked about this, right? And then the CO2 is this, CO is this, HC, NOx, you can see the fuel is this one, is just in 1 second, right? Electricity is 0, noise, and then there are other parameters, right? So for vehicle number 2, which is another vehicle that we had, as you can see in second 0, there is nothing, right? And then in second 1 also there is nothing. How? So what's the issue here? Okay, so the EV is also moving, right? We need to have some results for that. So, okay, the reason is we need to assign some parameters to EV. Okay, so let me see this. So here we need to assign these parameters, so which is the battery. Okay, so let's go here, and then the vehicle type, which is the EV, select the EV one from here, and then edit extended attributes, and then here there is a secret. So this is very hidden capability that SUMO team added to the SUMO, but this is very amazing. So you need to put some additional parameters here. If you don't see any parameters later on for other matters in this window, then you need to do something, this edit parameter. So let's say I'm gonna add this battery, the battery device for electric vehicle, and then the value is true. Okay, so then accept it, then don't forget it, and then you need to accept this one, and then go here again in processing, SUMO options, and again emission. Make sure that you select again this XML file, yes, and then okay, save everything, then go back to the SUMO CFG, run it, and now if you go to this XML file, now you would see that the electricity is changing. It has some values, right? So yeah, that's the idea. So now what I wanna do is the paper set some additional parameters like max battery capacity, max power, right? Constant power intake. So let's say here in this XML file, as you can see, there are not those parameters like max battery or things like the battery capacity, right? How we can generate basically those other parameters? So for that, first we need to go to again to the processing, and SUMO. And then here, if we go to the slides, and then we have here the battery. We need to search battery, okay, and then just select an output name, and then now if we save it and go here and then run SUMO CFG again, you would for sure see those parameters like battery, yes. And then as you can see, the total energy consumed is increasing, right? And the battery capacity is 35,000. So now if I want to change this 35,000 to 25,000, right? So I need to again come here. If you remember, then go to this vehicle type, EV, and then edit these edit parameters. I need to add another parameters here, okay? So that parameters, if I go to the slides here, let's say device battery capacity. How I can get these things is from here. So if you open this link in SUMO, just simply type emission output and electric. It will open this link for you, and then here you can see all of those informations, like the maximum battery and then things like that. There are other also informations here written. Okay, so then we have this device battery capacity, for examples, right? And then these values, and then the values are here. So device battery capacity. So what I need to say, device dot battery dot capacity, and then the value is 25,000, for example, right? And then if I accept it, then I need to save it again, these things. So let's run this. Sometimes it doesn't change. For that, you need to make sure that you activated that box. So here you can see 25,000. It changed, right? So what I'm gonna do is just a little bit talk about the analysis part. So I'm gonna add, I'm gonna change the traffic light. So I'm gonna decrease this duration to 2. Okay, the true movements from north to south, so that the EV basically will stop on the red. Okay, I'm gonna show you what would be the results. V2, and then I'm gonna click this one. Yeah, we forgot it to do it. Yeah, this is very tricky. And then I'm gonna just add save again. So let's run it again. And now let's see the results. So as you can see here, the results is very, it's just 6 seconds. Okay, I'm not sure what happened then again. So let's see. I think the electric vehicle is just passing by the inter. Yeah, okay. So this is a little bit tricky. You need to, you see, this results is just generated for 6 seconds, but simulation were beyond this, right? So something happens here. So let's go again to this netedit file, and then I'm pretty sure that we need to do again this emission output. So we need to again save it here. Okay, and then save. We need to do every time if there is a problem in the data. Okay, so now I think it's fixed. So as you can see, the electricity is positive value, right? And then sometimes, for some moment, it's negative value. This is the moment that the electric vehicle break, and then they regenerate basically the electricity to the battery, okay? So then what we can do is just copy paste these values and then go to ChatGPT and say, can you write a Python code to generate Excel CSV file for XML results coming from SUMO, and then copy paste some examples, some portions of the XML. So I'm gonna tell ChatGPT to change this format of data to Excel or CSV so we can use it for okay, so it generated a code for me. So let's go here, create a txt file, and then name it python.py, and then open this Python. Okay, okay, it generated a code for me. Let's copy this code and then go to create a Python code. So just create a txt file and then name it as python.py. Open this one using Visual Studio Code, paste everything here, and then I'm gonna just run it. So it just creates a CSV file for me, which is this emission, right? And what it did, it's just putting the XML file into the Excel, right? So from here you can just do filter and then just choose T0, let's say, or maybe T1 is better. And then let's say I'm gonna talk about just the electricity. So just take all of these values and then go to the insert and then charts, and then you can see on the x-axis we have time, on the y-axis we have electricity consumption. So as the vehicle is approaching to the intersection, the electricity is going up, and then when it brakes, the electricity goes negative because it regenerated the electricity to the battery, and then it goes to the zero because the vehicle is behind the red lights, right? And then again it will increase and decrease. So also other things are here, let's say the CO2 and everything is zero, but you can check other thing for T0. Yeah, okay, so thank you very much for watching this tutorial.